So in this video, we're going to look at an application of our sinusoidal functions. If you have a Ferris wheel and the maximum height of your Ferris wheel is 20 meters above the ground, and the minimum height is 2 meters above the ground, then we can figure out the amplitude, right? The amplitude in general is y max minus y min divided by 2. So it's going to be 20 minus the 2 meters divided by 2. 20 minus 2 is 18, and divided by 2 is 9. So that gives me an amplitude of 9. The midline, the formula for midline is the average of the max and the min, so y max plus y min divided by 2. So that's going to be 20 plus 2 over 2, which is 22 over 2 is 11. So the midline is 11. That's going to be helpful for sketching it. So we're going to sketch a graph of this. We want to actually sketch on here the midline where it's at. So the midline is going to be right about here. Just makes it easier to draw our graph if I sketch that on. The other thing I know is that it starts out at 2 here, so that'll be down here, and guests get off at 2 meters as well after 720 seconds to go all the way around. Halfway in between that, they'll reach their max, so the maximum will happen at 360 seconds, and the maximum is 20. The sort of quarter-way mark, or halfway in between the max and the min, would be 180, and we'll cross the midline at that moment, so that's sort of like, not an x-intercept, but a midline intercept, I guess you could say, and the halfway point here will be right there, halfway between max and min again. Then you can connect your dots with a nice function to see the sinusoidal function there. All right, and there it is. So there's our sketch. Okay, the period of this is actually just, well, how long does it take for the guest to go all the way around? And that is the 720 seconds. So the wave number k is 360 divided by that period. So the wave number is going to be 360 divided by 270, and 360 divided by 270 is a half. So k is equal to a half. Now let's actually look back at our picture and make sure that makes sense. So k is how much of my cycle fits within 0 and 360. So between 0 and 360, notice that half the cycle happens. I just go from the bottom to the top, which is half of the way around. So that makes sense with a k value of a half. Next, what I'm going to try and do is model this as both a cosine and a sine function. If I try modeling this as a cosine, what you can notice is that a regular cosine, a positive cosine, looks like this, right? It starts at a max, goes down to a min, comes back to a max. That's a positive cos. But a negative cos looks like this, starts at a minimum, goes up to a max, comes down to a minimum again. That's exactly what I have here. So what I have here is actually a negative cosine. So if I model it as a negative cosine, I don't need to have any phase shift at all. So that's what we're going to do. Modeling it as a negative cosine, I can say, actually, we won't use f because this is not just a general function, this is a height, so I'll maybe use h. And the variable is actually time, so I'll say h of t is equal to my amplitude. So looking back here, my amplitude is 9. So amplitude of 9. But it's going to be a negative cos function, so negative 9 here. Cos, my k value is a half. My variable is actually time, so I'll use a t. And then c, the midline is 11, so plus 11. So that's how we model it as a cosine. If we want to model it as a sine function, then I'm going to need a phase shift. So to figure out the phase shift, what I like to do is draw on the analogous sine function. A sine function starts at equilibrium and ends at equilibrium and hits equilibrium in the middle. Halfway in between those two equilibrium points, it hits a max, and halfway in between these ones, it hits the min. So that is the analogous sine function. What we're trying to figure out is, well, how far do I have to slide that sine function to make it look just like the cosine or the negative cosine? And you can see that that is 180 degrees forward. So this point slid forward 180, that point slid forward 180, this point slid forward 180. So when I'm modeling this as a sine function, I can say h of t is positive 9, because I was using a positive sine function there, a half for k, t, and then I'm moving forward 180, so minus 180 to go forward, and the same c value of plus 11.